I'm ending podcast. Still viewing on YouTube.
It looks
How's
like we're
the going?
live. The going is good.
Uh-huh.
How are you doing?
I'm great. I'm really good.
Cool. Yeah, so this is the algorithms mob. We're going to be
Yeah, the
writing an
mob.
algorithm to calculate the area of surface on the sand dune here.
Sounds like so much fun. You have to know the x coordinates and the y coordinates.
Oh yeah, we'll write an algorithm for that.
Yeah, nice.
Let's see. Where's my?
I think Seth is not going to be available today.
Okay.
Yeah, and of course, also maybe.
All right. Guess it's just us.
Mm-hmm.
What were we doing? We were talking about. Oh yeah, we were going to code all this up. Sorry, we're talking about binary search trees. Or did we did?
Yeah, we talked about binary search trees.
And we haven't coded any of this up yet, right? So.
Yeah, so we were supposed to do the doing and stop there. Yeah.
Okay.
I remember the last thing you said last time is that best way to get learning these things is to get a piece of paper and try drawing it on by yourself. Else you'll keep thinking that you know, yet you don't.
Yeah. 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 Did I say that?
I don't know. Was it not you?
It sounds like something I would say. No, that sounds about right. I mean, because yeah, I mean, it's obviously logically sound and it makes sense. And like, okay, yeah, I know this, but then you actually have to do something, and you kind of realize, oh, I don't actually know it as well as I thought I did.
Yeah. Because I think that came up because of how the simulations looked like they were like the simulations would make you understand them better, but still if you don't just do what the simulations are doing by yourself, if you don't create a tree and insert 5 on it by yourself, after you watch the simulations you'll forget what exactly happened.
Yeah. Practice. So, I guess we haven't started any of this. I guess they're using Python. Do you want to use Python or?
Yeah, we can use Python.
Okay.
The book is using Python, no?
It is for this example, yeah. I think it doesn't always use Python.
Does it switch between Rails and Python? I mean Ruby and Python.
Yeah, and I think it has some JavaScript in there somewhere too.
Okay.
I'm not sure. But yeah, I think it uses whatever language is best suited for that algorithm, whichever language kind of makes it easier to write that algorithm.
Okay.
But or if they're all pretty easy, then I guess maybe he flips a coin. I don't know.
Yeah.
So let's create a new file here. Let's see, touch. We'll call this bst.py. Then we'll just open that. Actually, that. Yeah, will this work? No, I don't want to do that.
That will open Xcode.
I guess I'll do it the hard way. Let me get some live sharing going here. Start collaboration session. All right. You get the private chat. All right. There you go. And
where did you share on Slack?
I put it in the private chat on StreamYard.
Oh yeah, okay.
You can.
Thank you.
Welcome. The Python extension is recommended for this file type. I have the Python extension. VS Code is weird. I mean, it's awesome. VS Code is awesome. Everyone likes it. Everyone likes it, so I'm sure it's good. I just
everyone but this.
For everyone but me. No, I just haven't used it. So. Except for these collaboration sessions.
So, like, you never use it on a daily? You use Atom?
No, I don't use Atom either.
You Vim?
No, although I might start using that soon because I have to. But no, I've been using Sublime, and I've been using
Sublime. Okay.
And I've been using when I've been writing Python, I've been using Charm, PyCharm.
Wow.
Yeah. JetBrains, that's it. JetBrains products. I like JetBrains a lot.
Oh, okay.
They got some good products. Although I haven't used their RubyMine. I have it installed, I think, but I haven't used it. I don't know. Sublime. I like Sublime because the editor is so lightweight. It just starts up like in a half a second. So open and it just boom, it's up and running. And I can get coding. Obviously, it doesn't have a lot of plugins and features, unless you can add them, but
you don't have to.
You don't have to if you don't want to.
Okay.
Let's see. All right. Is this kind of too small for you to see? It looks like, yeah.
Yeah, I can see. I can struggle and see. I can follow the code in the. I can quickly switch between. Yeah, I think that's cool.
That's good. All right.
So do we need to create the class node first to start with?
Yeah, we can also just copy that from our previous one.
Or maybe just import them if we have node.
Oh, I think we wrote it in Ruby, so never mind. Yeah, let's create a class node.
A file or just a class?
However you want to do it. Yeah, however you want to do it. You want me to create a file for you?
Yeah, a file for nodes for node, because we'll be reusing it over and over again.
Okay.
Or are we going to just use this one file? Maybe.
I have no idea. There's node, and yeah.
Pi, then you can do and we can self and this value.
Yeah.
On next node.
Actually, this is a tree, so we want like left child, right child.
Left child and right child, okay.
Yeah.
Left child and right child. And then maybe these ones we can default them to none.
Sure. Yeah.
Child equals child and self dot self dot value equals value. I think that's it.
Yeah. Looks
I'm not
good
sure
to me.
I'm just not sure if value is a keyword. Maybe you can do
Yeah, I don't think it's a keyword in Python. I think we're fine with value.
Yeah.
Yeah, it is not a keyword.
Okay, so you can just revert.
Yeah. Oh, yeah. I need to plug my computer in.
Yeah. These computers.
All right, so we got our node. Oh, jeez. Hold on, I'll be right back.
Okay.
All right, I'm back.
Yeah, so I just set us up in the
Looks
EST
good.
file.
Yeah, looks good. So
Is it maybe you're using? Can we try again?
Attempted relative import in non-package. Yeah, no, you have it correct. No, the syntax is correct. It's just saying that it's we're trying to do a relative import, but where it's not a package, it can only do like Python's a bit weird. So you have to create like a package in order to do this type of import. So we can create a package by creating a it's a init file, I think, init.py.
Yeah.
If I just do that, so now
I think it should be the underscores should be before the dot, the last set of underscores.
Oh. Correct. Let's remove that. Okay, touch, init. Ooh, that looks better.
Yeah. So do we need to create a directory and move them?
No, I think it's fine.
Okay.
Because this will say that, oh, this is now a package or module, I believe. So let's, I don't know. I'm not sure if this will work, but let's give it a try. So if we do Python, yeah, it didn't work. Attempted relative import and non-package. Oh, okay. Well, let's just do. All right. Yeah, let's try that. Yes. Still. Let's so let's do an absolute import then.
Okay.
Let me just remove this real quick. I don't like having it if I don't need it. So to do a absolute import, we need to get the directory. So we can just do, well, yeah, maybe we can just do this. Well, we shouldn't have to put the whole thing on. But yeah, Python's kind of, it might need that. And then this would be node. Valid syntax. Oh, it needs to be dots. All these need to be dots. Okay. So now import error, no module named. Yeah, because so it's now it's yelling that it's not a module. So we do need to create a not module, and yeah, I don't know. This is not going to work because it wants the users to be a module, which is not. So let's create a module. One branch above us, I believe. But that's, yeah, we do need a module if we want to import.
What do you mean a module? What do you mean? You do need a module? Create a directory and move all of them?
I'm not sure what I mean by a module. A module is kind of like a
file with init.py, a folder with init.py in it.
Basically, yeah. Yeah, basically.
No, that's a package. A package is a folder with init.py in it, and then a module is like this BST or node.py.
Right.
So actually, what if we try, okay, maybe I'll just comment this so that I don't undo what you've done. So
okay.
if we do from node import
Oh
node.
yeah. Oh right. That looks correct, sir. All right, it's working. Good, we don't need that.
Okay.
Perfect. Yeah, I usually do this in PyCharm, so it does like all the imports for me automatically.
Yeah.
I don't think I've ever written an import line.
Yeah, PyCharm makes it so easy, you know,
Yeah.
even with debugging.
Really? I haven't tried the debugging software.
The debugger, they have like a really nice debugger.
That's awesome.
Yeah.
All right, so yeah, so let's write. So what do we need for search search method? Looks like we want to be able to pass in a value that we're searching for.
Yeah.
And the root or a node to search through. And a starting node, basically a value and a starting node. And it's going to check that node. If it finds the value in the node, then it returns that node. Else it determines should we look down the left or look down the right. And then it recursively calls search, passing in the value and the new starting node. So.
Okay. So they start with the base case?
Yeah, so this is going to be like a recursive algorithm.
Okay.
And yeah, so our base case is if it finds it, we're going to return it.
Yeah.
And it also needs to check if the node is empty, and we'll just return the empty node. So we got two base cases there. One, if the node is null, then we've reached the end of our search and we can just return null. Otherwise, if we have found the value, then we can just return that node.
Okay. So get started.
Sure.
With the party. So we do if node dot value is none or equals to value. This is where we return node.
Yep.
Node.
All right.
So in search, so we check if node dot left node is not none, then we return search node dot left node. Then if dot right node. I'm not sure if this is how he did it.
No worries.
node is not none. We return search not the trend node. Yeah. Is that it? I'm not sure if I need to add the spaces. So here we first check if the value is none, then you return node.
Okay, yeah. So if, okay. Or if we have found what we're looking for, that's good. We return node. What if we have code like this? So we got our node, and we create a new node, and a node takes a value, right?
Yeah.
So what if we pass in none as the value?
So it takes a value, then left node and right node. Yeah, that will create. You mean you want to assign it to a variable new node?
Yeah. I mean, I guess none doesn't really make sense because it's a binary search tree, so it needs to be some value that is orderable. I guess what I'm trying to get at is this is slightly incorrect here. For it to be correct, we would need to do that. If node is none.
If node is none. Yeah, that's true.
Okay. So yeah, so this is good. And then we can clean it up a little bit more by also just getting rid of that there.
Yeah.
Because Python also has kind of like truthy, falsy values. So if node, so if this is none, then it's just going to short circuit. And
yeah. But problem about that is if someone passes an empty space.
Oh, wait a minute.
That's treated as.
Yeah, hold on. Wait, if none, that's going to be false. So yeah, so maybe we do need, sounds like, yeah, we do need that. If node is none, or no dot value. Well, no.
So I think what nowadays they do is
actually this is going to cause errors, because if, let's say if node is none, that's going to equate to true. Oh no, it won't cause errors. No, this is good. This is perfect. So if node is none, that's going to return to true. That's going to just return node. Also, if it's not none, then it's going to check the value. And if it equals, then it will return it. So yeah, that's perfect. All right, so moving on to the next line. So if it doesn't meet the base case, then we want to see what part of the tree we need to search on next, the left side or the right side. So here we wanted to check if node dot, I think did we call it left child? Yeah, left child and right child. So we want to do if node left child.
changing that.
Yeah. So let's see, if node dot left child, and then we don't want to check is not none. We want to check, is this what we're looking for? If node dot left child dot value. Sorry. If node if no dot value is less than the value that we're looking for, then we want to do the search on the left child. And then search also takes 2 arguments, so we need to pass in the value, and then no dot left child. Does that make sense?
Okay. Yeah, I think I'm still confused by the BST.
Oh, okay. So let's do this then. I'm going to delete this and have you rewrite that part.
Okay.
And then we'll also, I'll explain. Well, let's take a look at a picture actually. So let me see, what do we got here?
The value
Here
is less than value.
So here's kind of the algorithm. So we inspect the value at the node. If we found what we're looking for, then that's our base case. We return it. Otherwise, if the value we're looking for is less than the current node, so say like we're looking for 25, and we're currently at this node, so if the value is less, so if 25 is less than 50, then we want to search the left child. Mm-hmm. Else, if the value that we're looking for, else we're looking for a value greater than 50, and we just search the right child.
Yeah, true.
And then
yeah. So okay. So now we check if not that value is less than value. Now we search value with the not that left child. Then if not,
looks good.
Okay.
So yeah, so this is what they have for the algorithm. So you got, yeah, if node is none or no dot val. Yeah, that's perfect. That's what you got. Good job there. And then yeah, and then goes into an elif statement. Else, if value is less than no dot value, then return search. And otherwise, then it's greater than, and we can just do else.
Okay, I think what's your screen? So so if value is less than not dot value, not dot left child. That's if value is less. Oh yeah, okay. So they have elif here. So this happens this way. So if value is less than, because we are looking for the value, we have elif value is less than value. Then here we have else.
And we just need to put the return statements.
Return statements. Okay.
Yeah, I always forget those.
Yeah.
Ruby
has.
yeah. That's
Yeah.
what another reason why I use PyCharm. PyCharm will yell at me. You need a return statement. I'm like, okay. If you know I need a return statement, can't you just do it automatically for me?
Yeah. Okay.
All right. Let's. Well, I guess we can create. Do you want to create a? Well,
A test.
well, we need a way to build a tree. So this is a way to search a tree. We still need a way to like insert nodes and build our tree, and then we can test everything at the end.
Okay. So
I mean, we could build a tree manually, but if we finish writing out all these algorithms, we'll just be able to build a tree semi-manually, more automatically. So yeah, so the next one is going to be insertion. Yep. Do you want to?
then this takes a root. Oh yeah, I was just typing. I haven't looked.
Yeah, that's fine. Go for it, man. I was gonna ask you if. Oh, actually, yeah, just go for it, and then we can talk about it. You can kind of explain. Maybe you can treat this kind of like an interview, if you want. Just kind of talk us through what you're doing and what you're.
Okay. So we want to insert into a BST, and we have a value, and the root is maybe where the tree begins, I guess.
Yeah.
So first, I think we have the base conditions.
So.
Go ahead.
Oh no, you're fine. I was gonna ask a question, but I realized that no, this is fine. This is good. So okay. Yeah.
So first we check if value is none. And root is none. I think we should just return.
Okay. Sounds good. Safeguarding against none values being added to. Yeah. So we can't have a value that is none.
Yeah. And then now we'll check if root dot value is less than value. So I think if root dot value is less than value, then I think we should return a recursion of insert value root. So yeah, I think if this should be left child, and if root elif root dot value is greater than no.
So what I'm
should...
thinking here is
yeah, go ahead.
so the base case, I mean, what is insert supposed to do? What is this method supposed to do?
It's supposed to insert, it's supposed to create a node and it's supposed to create a node and insert it, add it to the if the value if the root has if the value is less than the root, it takes it to it makes it the left child of the root. And if the value is greater than root, it takes it to the right child of the root. Yeah.
So should that be our base case? Should the inserting method be our base case, or not? Or should the inserting...
So like if we have
or do we need to do like a search to see where we want to insert it at, and then when we get that search result back, we can just insert it there? Does that make sense?
So yeah, so you mean we need to find out where we should insert it first?
Not insert it first, but because the base case will be... Let me take a look at what the book has here.
So in that case,
yeah.
So if
yeah, so
if
okay, I see what the book is doing. And it's kind of doing what I'm talking about, just in a slightly different way. So I mean, we could either follow the book directly, or we can kind of mess around with this, kind of come up with our own way. But like a base case is a case that you want to hit. That's your end results. That's like, okay, this is what we were wanting to do, so let's do it. So the base case should be, we found the position where we want to insert the node, so let's insert the node. So the base case should be inserting the node, and then we're done.
So I would say the base case should be inserting the node. So if value, I don't know if this is correct for what you've just described. If root is none and value is not none, so we'll create new node. I'll just call it node equals node value, then root dot, I don't know, they just need to return node.
I guess we should kind of get an assumption out of the way.
Yeah.
Should we assume that root is never none? Should we always assume that when we insert a node to a tree, that tree does have a root?
So we assume that root and value are never none.
Yeah. I mean, we could do that. We could assume that. And then we can always write safeguards later. I'm like, okay. So this is an insert. So think of this, maybe I'm just asking, like, you don't have to do it this way, but
yeah.
Maybe think of this as a class. So this is an insert method for a tree class. I mean, it's very possible that a tree class could not have a root. Maybe it got deleted, but maybe just for this method, we just want to insert a node into a tree. Maybe we should assume that that tree already exists and that there is a root. So now we just need to determine where in the tree do we insert this value. So if we got a root, we want to check, okay, is the value less than root dot value, or is it greater than root dot value? And then depending on whether or not it's less than root dot value, then we're going to check, okay, well, if it's less than root dot value, does root have a left child? If it doesn't have a left child, if the left child is null, then we can just insert it there. Otherwise, if it does have a left child, then we'll have to recursively call insert on that left child.
Okay, so here we can check if root dot left child will have root dot left child equals to node value.
Mm-hmm.
We can just create that node here.
Remember, this is a recursive algorithm.
Oh yeah. Yeah.
I think line 19 is fine. We can just create it there.
Okay. Then if root value is greater than if value is greater than so if root dot right child is none,
yeah, so if right child, so if the value is greater than the root and the right child is none, then we can just add it to the right child of the root.
Okay.
Else the right child is not none, and so we want to recursively call insert on it.
That did a lot of tongue twisting to me.
So this looks pretty good. This actually looks like what the book has. So there's at least, there's one mistake, and
Yeah.
there's one improvement you can make for efficiency, whatever. So let's do this. So let's, why don't you explain to us what your algorithm is and what it does? And then let's see if we can figure out how to improve it.
So we have we want to insert a value to a tree that we. So we want to insert a value to a tree, and first we check if the value that we want to insert is less than what the value of the root.
And why do we want to do that?
Because in a BS tree, in a binary search tree, every value that's less than the root value are inserted on the left, and every that greater is inserted on the right. And then now we check if this value is less than the root. It means we are going to be moving to the left. The value should be inserted on the left side of the tree.
Okay.
You first check if the root has a left child. If not, you insert that child. This node as you insert this node as the child of the left child of the root. If root has a left child, you recursively call the insert on the left child of the root, so that it will check again if it will actually come and run the whole thing again and check for the root left child and right child.
So here we got, so if the child is none, then we're just going to add that node value to the left child.
Yeah.
Otherwise, left child is not none, and we want to recursively call insert on it, right?
Yeah.
So we need, so this line 19 runs regardless, right? There's an if statement here, and then line 19 runs regardless, right? So if the value is less than root.value, then line 19 always runs, regardless if left child is none or not.
So we need to return here?
No, not necessarily. So one strange thing about this insert algorithm is that, like a lot of recursive algorithms, you need return statements because you want to unwind. Yeah, there you go. Yeah, you just fixed both the issues.
Yeah.
Because so let me bring up the book, because now it looks exactly like the book. That's perfect.
But
because
okay.
Go ahead.
Yeah, I was just asking if I should go and delete it down here. So.
Oh yeah, go for it. Yeah. So a lot of recursive algorithms, you want to put in the return statements because you want to unwind. That's usually when the magic happens, when you're unwinding all those recursive calls. Because when you put in a return statement, And here, when you put in a return statement, then this gets added to the call stack, right? So
Yeah.
the call stack. And so if we're running a recursive algorithm, then at each return statement, it's putting in some address. Oh, that's not some address. So here it marks this. Okay, this is address 1234. So then after we've ran this, then we're going to return to this and finish running the algorithm.
Okay.
But there's nothing here that we want to run after we do this. There's nothing else that we want to run, so we don't really need to return to this point in time.
Yeah.
So we put a return statement if we want to return to this point in time, which some recursive algorithms, like for quicksort and all that, we needed to do that. But here we don't. There's no reason to return to this point in time because there's no code to run that needs to run or can even run underneath that statement. So we can just, we just don't even need to return. And so this never gets, so when it calls this method recursively, it never gets added to the call stack. So our call stack is empty, and then we either hit the base case or we don't. And then that's it. If we hit the base case, which is kind of weird because we got two base cases. One is right here, and then the other base case is right here, right? So, and they're kind of like nested. They're kind of nested under these if-else ifs. So good job, man. Yeah, so two base cases. And if we reach the base case, then we just add the node value. Else, we need an else. Yeah, if we don't hit the base case, then we want to else.
Yeah.
Then we insert. Otherwise, we don't want to insert. If we hit the base case and we don't want to insert, and we just want to fall out of the method, and we're done. Let's see. Yeah, insert. Yeah. Boom. And I guess we could, I mean, if you want to, we could just say like this is a base condition there. And then that's a base condition there. Yeah, one thing that helps me, like this is what I was saying, like writing down on paper, not like don't write down the algorithm on paper, but like it's called what is it called? Like walking? No, I forget. Anyway, it's called like walking the algorithm. That's not right, but something like that. But what you do is basically say, okay, I've got a root. Let's say I've got a root with the value 1, right? And so you write down, okay, here's my tree. Root is got a node 1. And then you're going to say, okay, I'm going to insert 5 into this. And so you say, okay, insert 5, pass in the root 1, and then you're going to write on the paper, is 5 less than 1? You say, oh, that is false. So then you're going to say, okay, now I go to line 21. Else if 5 is greater than 1, well, that is true. So now we go to line 23, and then is the right child none? So you would look at your root. Is right child none? Oh, hey, that's true. Now we fall into line 24. So now the root.right child, you can assign that to a new node and pass in that 1 dot value. And then you need to go over here and say, okay, new node, left child or right child is going to be none, and my value is going to be 1. And you keep doing that over and over. This is kind of an easy easy case to do that with because there's no like easy recursive algorithm to do that with because there's no return statements. Like Quicksort and some other ones, they can get kind of hairy. And is it Quicksort? I forget. My brain is so foggy right now.
Yeah.
But
Quicksort is where you what happens with Quicksort? It's you break it into two, and then no, you have a pivot, and then you break it, and I think have a like the pivot. Now you compare values. You take the middle value, put it as the pivot, and sort based on that.
That's right.
Yeah.
Yeah, I'm just looking at the code here. So yeah.
For Quicksort.
Yeah, the code that we wrote a while ago. So yeah, so we got a Quicksort
function.
I
think I had not started attending this.
Yeah, so we got very good. We got a pivot, and then everything left of the pivot, or we got to partition it, right? So we partition it, and then all the values that are less than pivot become on the left side. All the values greater than pivot go on the right side, and then we can and we just do it again. Yeah. And then merge sort. I don't know where it's at. Anyway, merge sort is another fun one too. But
I said you break it to the smallest, and then you sort the smallest and grow with it.
Yeah, exactly. You break it down until it's all like the only element, and then it's like, oh, hey, that's sorted. So now we can just. It's kind of weird, but it works.
Yeah.
Like you look at it, you think this shouldn't have a quick runtime, but it does.
Yeah. Yeah.
Strange.
Yeah, I think because it's easy. I think because now you are merging sorted stuff, so it's easy to know where something will go.
Yep. Yeah.
In the worst case, of course, you'll still be having of and when
that sounds right. Yeah, so good job, man. Sorry for I don't know if you felt uncomfortable doing that. I put you on the spot more or less.
No, I need it more and more, you know.
Yeah, I think it's good practice. I mean, I would I would so fumble through that it wouldn't even be funny. I'd do terrible. I need practice is what I'm saying too. But anyway, I'm glad I could give you kind of practice doing that. Maybe we can we can do that moving forward if you don't mind.
Yeah,
if you like it
more often. Yeah,
and then you kind of get used to just talking out loud while you're trying to code, and it might be better for if you ever have to do this type of thing in an interview.
Yeah, I had to do this type of thing like 3 weeks ago.
Oh man.
Yeah, you remember when I was telling you I was preparing for some test?
Yeah, I do.
Yeah.
How did that go?
Yeah, they responded, and I didn't make it.
Oh man.
Yeah, but I think I'll keep trying.
Yeah, definitely.
Yeah.
I need to start applying to some jobs here.
Yeah.
So I need to get myself out there.
I've been on it for a while now, so
yeah,
I think the whole of this month I've done like the past month I've done like 7 interviews.
Oh, nice. At least you're getting interviews. You're on the right track. So
yeah, I did my last one yesterday. So
I think my
just gonna take a
buddy,
break now.
yeah, someone I went to school with, man, he was doing like multiple interviews a week. It took him. He finally found a job like 2 months before he graduated. Finally got hired.
Mm.
But yeah, when he first started doing the interviews, man, he sucked because I was like trying to help him prepare, and he just absolutely sucked. He didn't know much. Like he had taken these classes before, and I'm like, dude, you should know this. Oh, I didn't tell him this. I'm like, but I'm thinking, dude, you should know this. But after like, he just kept on it, kept studying, and be like, and after a little while, he got better than me. So I was like, wow,
Yeah.
dude, good job. And then he finally it took him a while. It took him like a year, I'd say. But you know, he finally found a great job.
Yeah, it really works miracles doing it over and over again, you know.
Yeah.
I think that's like that's the only difference. Doing something two times and not doing again, or do you keep doing it over and over again?
Yeah.
I think
definitely
keeping at it is, yeah.
Do you don't do your interviews in English, or do you do them in English?
Yeah, they're all in English.
Oh, really?
They can't do interviews in Swahili.
No, why not?
No one uses Swahili in offices, you know.
Oh, really?
It's just like, yeah, it's just like the language on the street, like what we speak every day.
Oh, okay.
But at the official language, I think it's English.
Oh, interesting.
Yeah, though Swahili is the national language.
Yeah.
So like everyone speaks Swahili, but like when I meet someone right now, we'll just be speaking Swahili. But when I go to office, English.
That's kind of an interesting dynamic there.
We were colonized, you know. So yeah. Yeah. So maybe we'll start there next time.
Sounds good, man.
Yeah.
Nice. Yeah, let's so yeah, next time we'll get into deleting everything we insert.
Oh wow, nice.
So I think deletion I should let you go, but yeah. I think deletion is pretty straightforward, but all right, man.
Yeah, I needed to go somewhere, and yeah.
Okay.
Thanks.
Thank you.
And see you soon.
Yeah, definitely.
All right. Bye.
Bye.